This is lesson 10.3, Generating Equivalent Expressions. This is page 275. The essential question, how can you identify and write equivalent expressions? Explore activity 1. Identifying equivalent expressions. One way to test whether two expressions might be equivalent is to evaluate them for the same variable of the variable. Match the expressions in list A with their equivalent expressions in list B. So basically what's going to happen here is let's kind of pretend we didn't have this right here. That's where we're going to solve. One way to figure out, like, this is a matching, and we could just kind of guess and use our instincts, and we might even get some of them right. But to really prove which ones were equivalent, what we need to do is we need to take x out and replace it with just any number. And the book's telling us to choose 3. So what that means is we'd go through and we'd identify all the x's, and we replace them with the value 3. And then some of the ones on the right would be equal to some of the ones on the left. That's what's happening here. So this first one, instead of having 5x plus 65, we'd have 5 times 3 plus 65. And the second one would be 5 parentheses 3 plus 1, and then we do 3 plus 1, then we'd multiply that by 5. So that's what we're going to do actually below this right here, where it says A, evaluate each of the expressions in the list for x equals 3. So all of these are the same thing as what we had up above. In fact, I'm going to show you right now. Look at list A. It's 5x plus 65. Instead of that down here, we're going to change it to 5 times 3 plus 65. Because I've shown you plenty of times before that if you take a number out, or if you take a letter out and you replace it with a number, it becomes 5 times that number. So 5 times 3, that's going to be, I'll solve it down here. 5 times 3 is 15. We're going to add that to 65. 15 plus 65 is 80. The second one we're going to change x to 3, and we're going to do 3 plus 1 first. It's inside parentheses. We get 4, and then we get 4 times 5. That's 20. And the third one, we multiply first. We get 5 times 3. That's 15. And 15 plus 1 is 16. So now we're going to do the same thing on the right, and we're going to match up which ones are equal to each other. So the first one, we've got 5 times 3. That's 15. Plus 1, that's 16. So now we know that these two are equal to each other. I'm gonna list them. I'm gonna do some matching up here as well. So these two right here are equal, and that's actually not too surprising, because if you look at this one, this is 1 plus 5x, and this is just 5x plus 1. All we did was we just changed the order, so that's not surprising at all that those are equal to each other. How about this next one? We've got 5 times 3. That's 15. 15 plus 5 is 20. And so on the opposite side, the one in the middle was equal to 20, these two. So I'm going to change color just for fun. And these two are equal to each other. And that one isn't as obvious as the first set, because on the left we've got 5 parentheses x plus 1, and on the right we've got 5x plus 5. So the numbers are a little different, but they're still equal to each other. They both had a value of 20. And this last one I can just assume is going to be equal to 80. Let's find out. I've got 13 plus 3, that's 16. Times 5, 16 times 5 is 80. And so these two are equal to each other. All right, question B says, which pairs of expressions have the same value for x equals 3? In other words, we already matched them up, but it's now asking us to say which ones are equivalent or have the same value. I'm going to write it this way. 5x plus 65, that's equivalent to 5 parentheses 13 plus x. All I'm doing is writing on the lines the matching that I did earlier. And comma, because I've got 3 sets of answers that are equal to each other. Now I'm going to do the middle one. 5 parentheses x plus 1 is equivalent to 5x plus 5. And the last one is the one that I thought was really obvious. 1 plus 5x is equal to 5x plus 1. And all that happened there was we changed the order. There's actually a name for that, and we're going to learn about that on page 277. It's called a property. All right, let's go ahead and move on. Question C says, how could you further test whether the expressions in each pair are equivalent? So what we could do here is we could just change the value to something else. I'm going to prove it to you, and then I'll come back and help you answer this question C. So we chose earlier x equals 5. But we didn't have to, or we chose x equals 3, but we didn't have to. We could have chose x equals 5. And I can prove that to you. I'll do that in a couple spots. Check this one out here. If I took this x out and replaced it with 5, what would I have? I'd have 5 plus 1 is 6. and 6 times 5 is 30. So this value would be 30. And I'm going to go across to this one that I know it's equal to, or at least I think it's equal to from earlier. I'm going to take x out and make it 5. And so I have 5 times 5, that's 25, plus 5 is 30. So I've changed the value of x, and last time I did this I got, I think, 20, and this time I got 30, but they're still equal to each other. And watch how fast I could check this one. I'm going to make x equal to 5 here. What's 5 times 5? That's 25, plus 1, that's 26. And this one right here, I have 5 times 5, that's 25, plus 1 is 26. So what am I proving? I'm proving that I could change the value and I still have equivalent expressions. So I'm going to say you could change the value of x to a different number and test again. And this kind of goes along with my next answer. D says, do you think the expressions in each pair are equivalent? Why or not? They sure seem to be. Whether or not we can know for a fact that they're equal to each other, we can write they sure seem to be. They sure seem to be equivalent because we tested them with more than one value. I'm going to say we tested them for x equals 3 and x equals 5. And we'll just end it right there. Now we're going to learn later in this lesson how to truly test to see if expressions are equivalent. But for now, they sure seem to be. All right, good job. You're done with page 275.